The well-defined changes in plate motion that occur in the Labrador Sea and Baffin Bay, which have relatively limited external complications affecting them, make this area an ideal natural laboratory for studying microcontinent formation. Jordan Fathian, a researcher working on the study, said to phys.org. Fathian added that the rifting required to form a microcontinent is an ongoing phenomenon, and every earthquake could play a role in the next microcontinent separation. The aim of our work, Fathian said, is to understand their formation well enough to predict that very future evolution. When Greenland and Canada began shifting apart about 61 million years ago, the early separation started with a northeast-southwest movement of the distinct plates that coincided with the formation of the Labrador Sea and Baffin Bay. About 5 million years later, plate movement switched to a more north-south movement, creating the strait and the continental crust between them. The study of the Davis Strait proto-microcontinent and the theorizing around its formation does pave the way for understanding similar geographic structures. Our identified mechanism of microcontinent formation may be widely applicable to other microcontinents around the globe, and further study is merited to understand the role of plate motion changes and transpression in microcontinent calving. The researchers wrote in the study. Understanding the Holocene record of Greenland ice sheet change and the role of the ocean thereon is crucial for placing current observations of ice and ocean change into their longer-term context and for underpinning predictions of future change. The range of tools to be deployed from the RR's Sir David Attenborough during the Kang-Glac cruise provides an unprecedented opportunity to assess this change over the last 11,700 years. The mix of oceanographers, biologists, and geologists will collectively use a range of instruments to retrieve samples from rocks on land, from the ocean and from the seafloor to gain a comprehensive picture of this region, and its current and potential future response to environmental change. Using state-of-the-art capabilities of the RR's Sir David Attenborough and deploying advanced underwater robotics, such as the Gavia, operated by the Scottish Association for Marine Science, SAMS, the team will investigate modern interactions between meltwater expelled from glaciers and the inflowing warm ocean waters, as well as how this affects primary productivity in Greenland's fjords and coastal seas. Helicopters will also allow researchers to collect terrestrial rock samples. The marine sediment cores from the seafloor and terrestrial rock samples will reveal how glacier size, ocean temperatures, and carbon storage at the seafloor change during the Holocene.